Page 387, question number 72. It can be inferred from the passage that the isotope record taken from ocean sediments would be less useful to researchers if which of the following were true. Okay, well, the second paragraph and the third paragraph both talk about this isotope business. The second paragraph is really long. It's probably about as long as the rest of the passage combined, so I'm not just going to go and read all that out loud. Just know that we're probably going to have to look back at those two parts of the passage in order to verify our answers. So, can we infer from the passage that the isotope record indicated that lighter isotopes of oxygen predominated at certain times? Oh no, sorry, that the isotope record would be less useful if it indicated that lighter isotopes of oxygen predominated at certain times. No, in fact, choice A actually strengthens the isotope theory because, again, while they were looking for the heavier isotope of oxygen, that's O18, the more O18 there is, the more land ice there is. If there are times when there is more O18, then clearly there are also times when there is more O16. So the fact that lighter isotopes of oxygen predominated at certain times backs up the theory. And in fact, O16 should predominate more in times when there is less land ice, according to this theory. So A is the reverse of undermining the isotope theory business, the isotope record. B, it had far more gaps in its sequence than the record taken from rocks on land. So remember, in paragraph 3, we find out that this the ocean sediment isotope record is listed as being good because it has little variation globally and it's more continuous than the land version. If they find out that it actually has more gaps in its sequence than the record taken from rocks on land, then it would not be as good as stated by paragraph 3. So basically, I'm almost certain choice B is the right answer here. But let's check the other ones. C, it indicated that climate shifts did not occur every 100,000 years. Yeah, I don't know. I mean, again, it wouldn't necessarily need to coincide with every ice age, but it would need to coincide with some of them to still be a valid theory, especially since the author mentions that there are other contributing factors. So, yeah, I don't think we can, I mean, it's still kind of tempting though, so I guess we'll keep it. D, if it indicated that the ratios of oxygen 16 and oxygen 18 in ocean water were not consistent with those found in fresh water. Kind of tempting because, of course, it makes the record less clear. However, this whole thing with the ocean, with the O18 and O16 isotopes is that it really is only about ocean sediment. What happens with lake sediment is irrelevant to the theory. So even if there is less, or even if there are different ratios in fresh water, it doesn't matter because the theory is really only backed up by ocean sediment. And then choice E, it stretched back for only 1,000,000 years. Well, 1,000,000 years would still give you 10 100,000 year cycles. And so that would be a lot of ice ages to track. So going back 1,000,000 years would in fact be plenty. And in fact, what it says in line 41 to starting in line 42, it says the dated isotope record shows that the fluctuations in global ice volume over the past several 100,000 years have a pattern. So if it goes back 1,000,000 years, that's great. They've only tracked the last several 100,000 years. They still have more stuff to look at. So it's not E. Let's go back to C versus B. And so we know that an ice age occurs roughly once every 100,000 years. So even if the ocean sediment did not indicate that happened, that still wouldn't necessarily invalidate the isotope record, because we do know that the ice age occurred already. It doesn't. That would potentially invalidate the idea of ice ages. We know that those occur. We just need the ocean sediment stuff to coincide in some way with ice ages. So it's not going to be C. It is going to be B. Okay. Home stretch number 73. According to the passage, which of the following is true of the ratios of oxygen isotopes in ocean sediments? So the ratios of the oxygen sediment isotopes is in paragraph 2, the really long one. So we'll have to look back there for our answers for something that looks true. A, they indicate that sediments found during an ice age contain more calcium carbonate than sediments formed at other times. No, that's not true. We find out that, where was that? Oh, that the calcium carbonate is just formed from the water in the ocean, and it's just this. It's basically the storage mechanism for seeing how much of the various oxygen isotopes are there. There's not more or less of it. Just the stuff that there is what stores our isotopes. So it's not A. They are less reliable than the evidence from rocks on land in determining the volume of land ice. Actually, paragraph 3 told us that basically it's better, so it's not true. C, they can be used to deduce the relative volume of land ice that was present when the sediment was laid down. So that's kind of line 29-ish. The higher the ratio of oxygen 18 to oxygen 16 in a sedimentary specimen, the more land ice there was when the sediment was laid down. So that sounds ridiculously awesome. D, they are more unpredictable during an ice age than in other climatic conditions. No, we have nothing about them being unpredictable, actually. There's little variation, and it's more continuous. So not D. E, they can be used to determine atmospheric conditions at various times in the past. Well, saying that it's atmospheric conditions is definitely beyond the scope of the passage. Is really just about the amount of land ice. So it's not E, and it is, in fact, choice C. I almost deleted the whole thing. Number 74. It can be inferred from the passage that precipitation formed from evaporated ocean water has, and precipitation is, that's around line 20, basically. It says, so the evaporated ocean water is actually line 21 and 22. So because heavier isotopes tend to be left behind when water evaporates from the ocean surfaces, the remaining ocean water becomes progressively enriched in oxygen 18. So we want something like that. So precipitation, the water that gets away from the ocean, has A, the same isotopic ratio as ocean water. No, because clearly we just found out that the O18 gets left behind. So it can't have the same ratio. B, less oxygen 18 than does ocean water. So since the O18 is left in the ocean water, in theory, the precipitation, the rain that comes from water evaporated from the ocean, where it left more of its O18 behind, that precipitation should have less O18. So that sounds good. C, less oxygen 18 than has the ice contained in continental ice sheets. Really, it's about ocean water versus everything else, not about stuff in the air versus continental ice sheets. This is outside the scope. D, a different isotopic, I wonder if it's isotopic or isotopic. I'll look it up later. Maybe I'll report back, but it's not that important. We'll go with I don't know, I'll just say it however I feel like saying it. The advantage of the real GMAT is you don't have to read it out loud. Anyway, a different isotopic composition then has precipitation formed from water on land. Again, water on land is outside the scope of the passage, so we can't really infer anything about that. E, more oxygen than has precipitation formed from fresh water. Again, fresh water is the stuff on land, lakes and streams and stuff. Salt water, ocean water is really all that's in question. So that leaves us with answer choice B, less O18 than ocean water. Last one. number 75. It can be inferred from the passage that calcium carbonate shells, and we find out about them in the long paragraph too, so we're just going to have to hope that we can fetch the answer from that paragraph if we need to, when we need to support it. So are those shells, A, not as susceptible to deterioration as rocks? Well, we don't actually find anything about deterioration of calcium carbonate or rocks on land. So, I mean, no, that's outside the scope. Are they less common in sediments formed during an ice age? No, that's the storage mechanism. It doesn't. We have nothing about the increase or decrease in the substance. Just that the composition of the calcium carbonate is what changes. Are they found only in areas that were once covered by land ice? Wow, that's ridiculously untrue. It's found in the ocean, which is almost never covered by land ice. If it were covered by ice, it wouldn't be land ice because it would be over water. No, I suppose it's true that glaciers can extend out over the water, but I think that's what's going on in Greenland, for example. But no, they are not found only in areas covered by land ice, or that were once covered. Do they contain radioactive material that can be used to determine a sediment's isotopic composition? No, no radioactive material. Oxygen is not normally considered a radioactive material. So the process of elimination gets us to E. E says the calcium carbonate shells reflect the isotopic composition of the water at the time the shells were formed. And sure enough, line 24 says the degree of enrichment can be determined by analyzing ocean sediments of the period because these sediments are composed of calcium carbonate shells of marine organisms, shells that were constructed with oxygen atoms drawn from the surrounding ocean. And then the next line is the one I read before. The higher the ratio of oxygen 18 to oxygen 16 in a sedimentary specimen, the more land ice there was when the sediment was laid down. So because the calcium carbonate is formed by little critters in the water at the time in their shells, that reflects the isotopic composition of the water at the time. So anyway, that leaves us with choice E clearly as the correct answer, not just by process of elimination, but by support from the actual passage. And I think we'll stop there. I mean, I know we'll stop there. It's up to me anyway, but we had published that this is where we were going to stop. And yeah, we will start on page 388 next time. It's time to clear this off. So next time we will start on page 388 with question number 76. And we will not have a broadcast the next 2 days. I am taking off the next 2 days for New Year's holidays, but we will be back on January 2nd, as normal, with the aforementioned question. So, you've been watching Grockit's OGTV. This is the GMAT edition. I'm Jim Jacobson, and this is using the 12th edition of the guide. Stay tuned next time. We will continue with reading comprehension, and we're actually getting relatively close to done. There are 139 questions, and we get through 7 to 10 per time. I guess we're about half done. So we'll be done within a few weeks. A couple weeks, I guess. So anyway, see you next time.